Welcome to this video. Today I want us to learn something important under more concept, and that is mass ratio. So we call it mass to mass ratio. So how exactly do you use this to find the other mass of a substance, especially in the event where there's a reaction taking place? So I'm going to give you an example, then you follow me from there. So let's say we have this reaction, sodium, a solid, reacting with chlorine, a gas, to give us sodium chloride. In this case, we'll treat it as aqueous. Just treat it as aqueous. Right? So, is this equation balanced? Of course, we can balance it like that, like that. Then, let's say we've been given 2 grams. Not say 2 grams. Let's say we've been given 1.5 grams of sodium that react with chlorine. How do we find the mass? Okay, how do we find the mass of chlorine that reacted? Okay, so if 1.5 grams of sodium reacted with a certain amount of chlorine to give us sodium chloride, but what is that amount of chlorine that reacted? And I'm going to explain this in terms of mass to mass ratio, not mole ratio, but mass to mass ratio. So mass to mass ratio allows you to compare the masses of reacting parties. So in this case, we've got sodium, so you put sodium there in ratio to chlorine. Are we together, right? So if this is the case here, what do? You get the mass of the first element that has been given. So we have been given 1.5 grams of sodium, but we haven't been given the mass of chlorine. It's what we are looking for. Now, which other mass, if we are saying mass to mass ratio, which other masses are we going to compare? Well, we are going to compare their relative molecular mass. And how do we get the relative molecular mass? Is the first thing is look at sodium. The mass number of sodium on the periodic table is 23. But how many are they here? There are 2 of them. So you end up getting 46 grams. We do the same for chlorine. Chlorine on the periodic table is 35.5. But how many are they? There are 2. So 2 multiplied by 35.5, we get 71 grams. So this is what we do in terms of mass to mass ratio. Then you cross multiply. One thing that you need to take into consideration here is that we include the moles in front of that element or compound in order to get your relative molecular mass. Are we together? I'm calling it relative molecular mass and not molar mass. There's a difference, please. So now you cross multiply. After crossing multiply, you discover that 1.5 is multiplying 75. So it's 71. Which is giving me 10.65. So I'm getting, after closing multiply, I'm getting 106.5, okay, gram multiplied by gram, because there's a gram and a gram. So is equal to 46 gram, then x. So we divide by 46 gram, we divide by 46 grams. So 1 gram and 1 gram, gone. That and that, gone. So we have this one being divided by 46, which will give me 2.31 and so forth. It's a rational number. So I'll just leave x to 2 decimal places, 2.32 grams of chlorine that reacted with 1.5 grams of sodium. So this is how we use mass to mass ratio in case someone didn't explain to you properly, but now I know you know.